Okay, so this is going to be a video on what we're going to call cluster analysis. Okay, cluster analysis is going to be considered for this course a high-level algorithm. We're not going to get too deep into implementing it. Mostly what we're going to do is put data through the algorithm and then examine its results. Essentially, what happens here is you're going to take a set of observations, usually people, um, and take a series of measurements on them, and then try to divide those people into clusters using what is called as a non-supervised algorithm. Now, what do I mean by non-supervised? It means that you're not going to give the computer the rules for how to put the people into clusters. You're going to give the people the computer the data and have it figure out how to cluster the people. Okay, so the easiest way to visualize this is only to take two measurements on the data. So let's call it X and Y, and we'll create a data set that is in X and Y. Okay, and perhaps I have created this in such a way that there might be some obvious clustering. Okay, so what we do here is we want to try to break this into groups, and we want these groups, maybe we'll make a group here, we'll make a group here, and we'll make a group here, and we want to do this in such a way that we can measure these, and we're going to do two types of measures. One is called an intra cluster measure, and the other is going to be called an inter cluster measure. Yep, too many U's. In an intra-cluster measure, we want all the dots, the distance between the dots within the cluster. That's going to be the measure of that, right? And so if I start like looking at distances between the dots in the clusters here, right? And in this one, I guess I need some more there, right? There we go. All the measurements between the dots in the clusters here. Okay, these are what are called intra-cluster measurements, and we want these, if we have a good set of clustering, to be small. Okay, so we want these measurements to be tight little clusters, right? Interclustering, right, so that's here, is how far are the clusters from each other. So what we would tend to do is take the two elements of the cluster that are closest to each other, maybe these two and maybe those two, and we want these measurements, so these are the intercluster measurements, we want these to be relatively large. Okay, so we want the clusters to be far apart, but when they are looked within the cluster, we want all the clusters to be as close together. And when we've got situations where the intra-clustering is small and the inter-clustering is large, then we have a pretty good clustering situation. Now, the tool that we're going to use for this is going to be something called a k-means algorithm. And we're not going to implement this thing by hand because it's like tedious and very difficult. It can be carried out by hand, probably in like two measurements, but not as something that's typically done that way. So let's figure out how this thing works. Okay, so let's kind of redraw our thing. Okay, so we're going to kind of redraw our two-dimensional map here. X's, Y's. Two things, and we're going to make it look like it did before with what might be kind of three clusters, okay? And try to understand how k-means works. So what we do in k-means is we start by trying to pick three of the dots, and we're going to say this one, and maybe this one, and maybe this one. So let's say we picked poorly, right? And what we're going to do is kind of play around with things. And we're going to say, okay, which of these are closest to these three dots, right? So maybe to my yellow ones, I might get the ones closest to yellow. Maybe kind of that group, right? Okay, and then we look at the red ones. Then we go, okay, so we kind of got that group. And then we got the blue ones, which probably might be that group. Okay, so what do we do? Okay, so we rethink and we say, all right, of all the dots that are in the red group, where is a likely place to put the center? So, like, basically I add up all the x and y locations of this and find the mean and say, okay, that looks like kind of like the center of the red dots. And then I say, well, where's the center of the blue dots? Okay, well, center of the blue dots looks like it might be about here. And where's the center of the yellow dots? And center of the yellow dots might be somewhere around here. Okay, so what am I going to do? Okay, so what I'm going to do is I'm actually going to go in and do some erasing. Let's see if I can get that to work. There we go. So I'm going to get rid of the original clusterings. So get rid of that red there. Okay, get rid of that yellow. And that blue that I originally drew to kind of cluster these things together. So eraser's not perfect here, but it's getting rid of most of it, right? Trying not to get rid of the green dots though. Okay. So these are the ones that I don't want to use anymore. Alright. So let's bring back our pen here. Right, maybe our pencil. And now, yeah, that's what we want. Maybe this. Yeah, there we go. Alright, so now using this new red centroid, this new yellow centroid, this new blue one, we're going to redraw the clusters. Okay, so here looks like the ones that are closest to my new red one, right? And if I look at the ones that are closest to my new yellow one, right? I think I'm going to get these guys here. And if if I want the ones that are closest to my new blue one, I'm going to get these guys down here. And if I were to look again and like run the algorithm one more time and say where's the center now, then the blue center is probably going to move to like here. The red center is probably going to stay pretty close to where it is. The yellow center is going to kind of keep moving here. And what will happen here is ultimately over time, these three centers will just land in the same place and stop moving. And you'll end up with 1, 2, 3 solid clusters. Okay? So this thing kind of does two shifts. It places centers and forms clusters. It finds center of formed clusters by using a means calculation. So it calculates the average in both directions. And then it comes back here and it replaces the centers and forms new clusters. And it keeps doing that until the centers stop moving. And then when the centers stop moving, it says, okay, I'm done. I have my 3 clusters, or however many clusters I need, and I'm good to go. Now the question is like, should there be 3 clusters, right? Is 3 good? Like, should this have only had 2 clusters, or should it have 4 or 7 or whatever? And if you get far above like 7, it starts becoming impractical, because then like at some point every single data point becomes its own cluster, which is not usual. So what we do is, this is where these measures come in. The number of clusters that produces the small intra cluster reality and the large inter-cluster distances, right? So these are both distances, intra-cluster distances, and the large inter-cluster differences is going to be the number of clusters that we're going to make. And we're going to call that number K. So this is where the word K comes in when we talk about the K-means algorithm, right? So it's 1s, not 2. So it's K, the number of clusters, and then we keep taking the means of those clusters until we can find their centroids and where they stop. And what we'll find is that this will break into groups that once we step back and like apply reality back to this, and we understand like what X and Y are, like X might be shoe size, right? And Y might be, I don't know, average income. And this group here would be like big feet people who have a small average income. This would be small feet people who have a small average income. This would be like slightly above average shoe size people with high income. And now I've got like 3 target groups that I can do some sort of either marketing to or organizing around or things like this. So we'll look at this more deeply in class. But this is where we are. All right. So there you go. It's a quick and dirty, easy introduction to cluster analysis.